Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of modeling slope-intercept form. This is standard 8.5i in the great state of Texas, and we are using item number 5 of the 2024 released STAAR test. This is a new item type called drag and drop, and if you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So this is a 2-point problem. We need to drag some of these into boxes, and you notice that we can only use each one once. Sometimes drag and drops can be used twice. So if we were to randomly select one and just try to move on, it is going to give us the error message 2-point problem. So let's make sure that we get both points. So we have a table, and it shows several pairs of x and y values, and it is a linear relationship. So that's going to be helpful because if it's a linear relationship, right, then we are going to be able to use our slope-intercept form to be able to represent it. And so we need to create that slope-intercept form, and all they're going to give us is x and y. Well, let's look at our reference materials because we are going to find, right, slope-intercept form. In case we don't have it, it's that very top line right there. Y equals mx plus b. All right, so we can put that there. Y equals mx plus b. And you can at least learn what the m is on our reference materials. They don't tell you what the b is, but we can solve for that. The m is the slope of the line, right? So we can use this equation. It's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's change in y over change in x. And so that's rise over run is what we typically think of. And if you see the actual graph, you can usually just count the number of spaces that two different points move. But when we have an x and y table like this, we need to be able to calculate it. So it doesn't matter what your x and y values are. You can choose any ones. If there's any zeros or ones, you always want to choose that because it makes for easier calculation. I'm just going to choose these two because they look fairly simple. The key is it doesn't really matter which one you choose. All right, so I'm going to choose this as my x sub 1. I'm going to choose this as my y sub 1. And I'm going to choose this as my x sub 2, my y sub 2. You can flip those, and I'll flip those in just a moment to show you that it doesn't really matter which ones you do. Just make sure that your sub 1s are across from each other and your sub 2s are across from each other. Those need to be paired. So plugging this in, my y sub 2 is 8. My y sub 1 is 5. My x sub 2 is 8. And my x sub 1 is 4. So 8 minus 5 over 8 minus 4. So that's going to be 3/4. If I had flipped these, right, and I said I wanted this to be my x sub 2 or my y sub 2 and my y sub 1 and my x sub 1, x sub 2, still get the same answer. Watch this. This would end up being my y sub 2 is 5 minus my y sub 1 is 8, so that's going to give me a -3, but that's fine because take a look what's happening in my denominator. My y sub 2 is 4, my x sub 2 is 4, my x sub 1 is 8, so that's also going to be negative. It's -3 over -4. The two negatives make 3/4. So 3/4 is my slope, my m. So now I can use my slope-intercept form. Y equals 3/4 x plus b. I'm going to choose any two values, plug those in. Any of them work, so let's just plug this in. Let's say y equals 1. So I'm going to say -1 equals 3/4, and my x is going to be -4. I picked that just because I want those two to cancel, right? So I'm going to say -1 equals, and then 4, and that -4 is just going to make it a -3, right? Plus b, and what I'm doing is I'm trying to solve for b. Add 3 to both sides, and I get 1 plus 3 is going to be 2, so b equals 2. So here's my final equation. Y equals 3/4 x plus 2. If you want, you can plug it into any of those to verify, but that is going to be our answer.